When we think about the word chaos, we picture things that are just completely random, unpredictable, like a leaf fluttering in the wind. But what if that's not the whole story? What if, hiding underneath all that messy disorder, there's a set of universal rules, a secret code that actually governs how things fall apart? Well, that is the huge mystery we are diving into today, and it comes straight from a really fascinating research paper. I want you to think of this as a scientific detective story. See, scientists had this theory about a universal number, a kind of mathematical signature for chaos, and they set out on a mission to find it everywhere.
And this big idea, it has a name: Feigenbaum-universality. It's this really beautiful, tantalizing idea that totally different chaotic systems, we're talking everything from dripping faucets to super complex equations, might all be marching to the beat of the exact same mathematical drum. So our whole investigation today is about putting that very idea to the ultimate test.
Okay, so any good detective knows you have to check your equipment before you head out to a crime scene, right? And that's exactly what these researchers did. Before they went searching for this universal code in uncharted territory, they had to make sure their tools were perfectly calibrated. Their testing ground was a mathematical system they call Class C. Now, this is super important. Class C is the one place where they already knew for a fact that this Feigenbaum code existed. That makes it the perfect benchmark. If their tools can find the code here, they know they can trust them anywhere else. So, what is this special tool they're using? It's a really sophisticated technique called the Padé-Borel method. The easiest way to think about it is like a mathematical magnifying glass. It's built to sift through tons of numbers and spot a very specific kind of fingerprint, what scientists call a Borel pole. And that fingerprint, that's the signature of the universal code they're looking for. And what happened when they pointed their magnifying glass at Class C? Bingo! A crystal clear, strong signal popped up, right at the value S approximately 0.19. And this number, it's precisely the fingerprint that the Feigenbaum theory predicted. The clue is exactly where it's supposed to be. So the verdict on this first test is in. A perfect match. The calibration was a total success. This tells them their tools are sound, their method is reliable, and the team is ready to go. Now they have the confidence to take that magnifying glass and start searching in the great unknown. All right, with the tools all calibrated, the real investigation can finally begin. The scientists turn their attention to brand new mathematical universes, places where nobody knows if the Feigenbaum code exists. The hunt is officially on. First stop is a system they call Class A, and this place is a totally different mathematical world from Class C. It's got its own rules, its own unique behaviors. So the big question is that universal code for chaos also hiding in here? The team points their magnifying glass and takes a good long look. And the result is a complete shock. There's nothing, absolutely nothing, no trace of the signal they were looking for. The data doesn't have any of the right patterns, and that mathematical magnifying glass finds no fingerprint at all. In Class A, the universal code is just gone. So this is a major twist in our detective story. It looks like the universal code isn't so universal after all. But there's one more place to check, a third, even more complex system called Class B. And this is where the case gets really weird. Because in Class B, at first, they actually find something. A faint little signal appears, a potential clue. For a moment, it looks like they might have found a different kind of code. But then, they adjust their magnifying glass. They switch to a more powerful, higher resolution version of their method, and poof, the signal completely vanishes. It was just a mirage. And the paper explains it perfectly. This potential clue was basically an illusion, something that only appeared because they weren't looking with enough precision. As soon as they applied a more rigorous analysis, when they zoomed in with a more powerful lens, so to speak, the feature just wasn't there. It wasn't a real fingerprint after all. So you might be thinking, this whole investigation was a bit of a failure, right? They didn't find the code in Class A or Class B. But here's the amazing thing about science. Finding out where a theory doesn't work is often just as important as finding out where it does. A no can be an incredibly powerful answer. So let's recap the whole case file. In Class C, the fingerprint was found, which proved the tool worked. In Class A, the fingerprint was nowhere to be seen. And in Class B, what looked like a hot lead turned out to be a complete false alarm. So what's the big headline here? The investigation delivered a clear, decisive verdict. That beautiful, simple idea that one single rule, the Feigenbaum code, governs all paths to chaos, well, it's just not true. The universe is more complicated and honestly way more interesting than that. And this result isn't a failure, it's a huge discovery. It literally draws a line in the sand, showing us exactly where this famous theory applies and where it doesn't. It proves that the Feigenbaum code belongs to one specific family of chaos. And that's crucial because it stops other scientists from wasting time looking for it where it can't be found. Most importantly, it opens our eyes to a much richer, more diverse world of chaos, suggesting there could be entirely different undiscovered rules out there. And that's really the thought I want to leave you with. By proving that this one universal code doesn't exist, this research opens the door to an even bigger mystery. If Feigenbaum's code is just one of many, then how many other families of chaos, each with its own unique fingerprint, are still out there, just waiting for us to find them?